Okay, we're going to take a look at conditionals, and we're going to specifically look at how conditionals turn programs into trees. And another word for conditionals is called branching in a program. And so we're going to try and understand why we say branching and how that connects to if statements. So we have some code over here. And this code says if you input a letter, then first we're going to ask the user to input a letter that will become X, and then we say Y equals 3. And if the letter that the user inputted was A, then Y is going to be incremented by 1. Otherwise, Y is going to be decremented, and Y is going to be incremented by 1. And then if the letter that was inputted was a B, then we're going to increment Y by 10. So this is the basic plan. So what we're going to do is use this same accounting technique that we had before. And so we're going to say, okay, we're going to start with some value X here. And this X value is going to be a question mark. We don't know what it's going to be because the user has to input something. And then we have Y, and Y is going to be 3. So this is working better now. Okay. And now we have this if statement. If X equals A. And we can check this here. Does X equal A? Well, we don't actually have any idea yet because the user hasn't put anything in here. So one of two things could happen. We could either be in the case where X does equal A, and we'll just keep Y the same for now. Or we could be in the case over here where X equals still a question mark, but not A. And Y equals 3. Okay. So we'll just draw a box around here. And then what happens if A is equal to 3? If A is equal to 3, we're going to increment Y by 1. So I'll cross this out and write 4 here. And if else, Y is going to be decremented by 1. So we're going to end up with 2. Okay. And now we continue. So in either case, Y gets Y plus 1. So this will become 3. And we're going to cross out our 4 here. And now we're going to have 5. Okay, great. And now what's the next line on the agenda? Line 8 in our code. If X equals B. Well, we know over on the on this side here, we know that X definitely doesn't equal B. We could only be here if we had A. So say we're done with that. And now here, well, we said we don't know what X is going to be, but it could be two things. We don't know what X is, but it's definitely not A. So it could still be B. At this point, it could either be X could be B, right? And then Y is going to take the Y value from here, is 3. Or, draw another one here, X could be something except it's not A and it's not B, right? Then Y still is going to take the same value. If we take another look at our code says if Y is equal to B, then we're going to increment by 10. So we'll cross this out, and now we have 10 here. 10 here. Okay, great. This is another. Now, if you look at what we have, we started up here, right? And we kind of branched here, and then we branched here, and then we branched again. Right? And this is how code, the program code that we have here, actually turned into a tree. Now, we don't really, this maybe doesn't look a whole lot like a tree to you, but what if we flipped it upside down? I'll draw it again over here. If we drew it like this, we have one going here, and then one going over here, and then kind of maybe like that. It kind of looks like a tree, a pretty pitiful tree. As we'll learn later, This is actually a special data structure called a tree in computer science, despite its poor resemblance to a actual tree. But if we had lots of more branches, you can imagine, now it kind of starts to look like something like a tree. So this is why sometimes when we talk about conditionals, we're talking about branching in a program, because this conditional, this if statement, allows us to go down different paths through the execution of a program. So sometimes when we're talking about programs, and specifically when we're talking about branching, and oftentimes in program analysis, when we're trying to analyze what a program does, we will say that, does this program have branching in it? Are there if conditions, if statements? And so this is just a little bit of sort of bonus knowledge to know about if statements, is that when we have an if statement, we actually create a tree of possible computations that might happen in the future. And this is how we would draw that out.